Hey everyone, and welcome to this explainer. Today, we're diving straight in and unpacking the architectural blueprint of modern web applications by looking under the hood of React. Our goal here is to take this massively complex ecosystem and break it down into a highly visual format. We want you to see exactly how today's digital world is engineered for absolute speed. So, what actually powers the fastest web apps we use every single day? Think about your daily browsing habits for a second. When you're endlessly scrolling through your favorite social media feed or clicking around a modern streaming platform, you've probably noticed that the pages don't just blank out anymore. The browser doesn't do that annoying white flash while it fetches new information. Everything just loads instantly. It seamlessly responds to your taps and clicks as if it's a native app living directly on your device. Have you ever wondered how they actually pull that off? Well, the secret sauce behind that frictionless experience is React. It's a massive, unbelievably popular JavaScript library used specifically for building fast, dynamic web applications. But here's the thing, it wasn't just built to be fast. It was actually created by engineers at Facebook to solve a huge architectural headache. They needed a way to keep the user interface stable and lightning fast when totally unpredictable data, like chat messages and constant notifications, were pouring in and causing these crazy cascading bugs. It literally changed how we handle data on the front end forever. Okay, let's look at our roadmap for today. First, we'll cover the React philosophy. Second, building blocks, components. Third, data flow, props and state. Fourth, dynamic UIs and forms. And finally, the component lifecycle. Let's get right into it. Starting off with Section 1, the React philosophy. Before we even talk about building anything, we have to understand the massive architectural shift that React actually relies on. Back in the Wild West of traditional web development, clicking a link meant the server had to build a brand new HTML page entirely from scratch, send it all the way over, and your browser would do a full, clunky page reload. The single-page application, or SPA model, flips this on its head. It initially loads just one single web page, and then it intelligently updates only the specific pieces of content that need to change exactly when they need to change. This is what gives you that smooth, app-like user experience. But that brings up a crucial question, right? How does React know exactly what parts of the page to update without just reloading the whole shebang? The secret weapon here is something called the virtual DOM. Think of the virtual DOM as a highly detailed draft blueprint. Instead of React going in and directly modifying the actual web page, which computationally speaking is a very slow process for a browser, React creates a lightweight virtual representation of your interface right in its memory. When a piece of data changes, React updates this virtual blueprint first. It compares it to the old one, calculates the absolute bare minimum number of changes needed, and only then executes the update on the real web page. It is just incredibly efficient. Moving right along to Section 2, building blocks, or components. So to actually sketch out these UI elements, developers use something called JSX. Basically, it's a syntax extension for writing UI structures. To put it simply, JSX allows developers to write code that looks pretty much exactly like standard HTML, but, and this is the cool part, it's completely infused with the mathematical and logical power of JavaScript. It's how you draft the visual layout of your app, declaring exactly where a button or a text box should live, right alongside the actual logic that powers it. Now, think of functional components literally like custom Lego bricks. You can engineer a specific button module, a profile module, or even a highly complex navigation module. And component composition? That's simply the architectural practice of snapping these isolated pieces together to build up massive, complex user interfaces. Instead of building one giant tangled web page where everything is connected, you engineer tiny, reusable, perfectly isolated units and just combine them to form the final product. All right, Section 3, data flow, specifically looking at props and state. A modern web app isn't just a static painting. Those modular Lego bricks we just talked about need a seamless way to communicate and remember data. React handles this through a really strict division of labor, using props and state. Props are basically instructions and data passed down from a parent component to a child component. For example, if you have a user profile module, it passes down a username prop to the profile picture module. The data always flows downwards. State, on the other hand, is private. It's internal data managed strictly by the component itself. It's the localized data that changes over time within that specific little module. Let's look at how state actually operates in the real world. User events, clicking a button, hovering your mouse, or typing on a keyboard, actively trigger changes in the application. When those events happen, the component uses a handy little tool called useState to act as its short-term memory. So if a user clicks a like button, an event fires off, the component's internal state updates to remember that new like count, and boom, the virtual DOM immediately steps in to efficiently re-render just that one tiny section of the screen. Section 4. Dynamic UIs and forms. To adapt visuals on the fly, React leans heavily on two really important concepts. First up is conditional rendering. This is where the app uses logic to mathematically evaluate what to show you, like, say, routing a validated user directly to their dashboard versus showing a guest the public login screen. It adapts dynamically based on the current state. Second, lists and keys. This is how React handles massive amounts of repeating elements without breaking a sweat. If you render a list of 100 emails, React assigns a totally unique key to each one. This way, if you archive just one single email, the virtual DOM knows exactly which item to remove without wasting precious computing power re-rendering the other 99. Of course, to make an app genuinely dynamic, you need complex user input, and forms are the primary gateway here. In React, the very millisecond you strike a key in a search bar, that character is instantly logged into the component state. The application knows exactly what you're typing in real time. This incredibly tight, hyper-fast data loop is exactly what allows modern web apps to instantly validate your passwords, filter massive databases on the fly, or drive complex UI updates right before your eyes, all without ever dropping a single frame. And finally, Section 5, the component lifecycle. Believe it or not, every single component we've engineered today goes through an actual, definable lifespan within the application. First is the mount. This is the component's birth, when it's instantiated and inserted into the DOM for the very first time. Next is the update phase. This is its active lifecycle, where it's constantly reacting to new props, internal state changes, and all your user interactions, adapting its visuals in real time. Finally, the unmount. This is the calculated death or removal of the component when you navigate away. It cleanly clears it from the screen in the browser's memory to prevent any performance leaks. So how does understanding these building blocks change the way you interact with the web? The next time you're flying through a lightning-fast app, you'll probably picture that invisible virtual DOM calculating changes and all those components adapting in milliseconds. But here is the real question I want you to walk away with. If React revolutionized the web by abstracting away the browser and giving us these perfect modular components, what happens to front-end development when AI starts writing and assembling these modules for us completely on the fly? Well, you now have the architectural blueprint to understand the modern web, and honestly, whatever comes next. Thanks for joining me on this explainer.